Looks like you're muted there, Michaela.
Thank you.
Yeah.
Hello, everyone. Welcome to the April webinar on severe weather brought to you by the Northeast South Dakota AHEC and the South Dakota EMS Association District 4. Like usual, please make sure that you are signed in via the EMS online portal through the state website. If you're an advanced EMT, feel free to shoot me an email or even Kyle Moser an email, which I'll throw his email in the chat box once we get started, as well as if you did not put your EMS number or license number on the registration, to please throw that in the chat or send us an email as well. With that being said, I'm going to hand it off to Ryan.
Great. Thank you very much, Michaela. And I'm looking forward to talking about something other than snow and cold after this pretty brutal winter. So we'll go ahead and get started here. All right, so the topic today, severe weather. A little bit of a change of pace from, again, the cold and snow. I still have some piles of snow in my yard. So it's probably going to take a few more, maybe weeks, hopefully not, but to get rid of those. But yeah, severe weather season is right around the corner. Before we start in on that, just a little bit about the National Weather Service. And so this is kind of an overview of the entire country. There's 122 different forecast offices. The Weather Service itself began in 1870 by President Ulysses S. Grant. So NWS Aberdeen has just portions of central South Dakota and northeastern South Dakota into west central Minnesota. Our mission is to provide weather, water, and climate data, forecasts, and warnings for the protection of life and property and the enhancement of the national economy. So we are staffed 24/7, 365, because the weather never stops. And so we have to always be keeping an eye on it and monitoring the conditions. There are 16 of us in this office that are meteorologists and 22 total staff members. And so, again, always somebody there, always somebody to take phone calls or answer questions on social media, and keeping an eye on things. I have been with the National Weather Service for about 9 years now, and I got interested in weather way back when I was about 8 years old. I used to be terrified of storms. I would be the one to go in the basement, go under the covers, just do whatever I could to get away from the threat. Just terrified, like most kids are. But there was a storm that came through southern Minnesota back in 1998 in May that did a lot of damage to my hometown. It ripped off the roof of my daycare provider. It actually knocked down my aunt's house. And after that moment, I just became hooked. I didn't really want to do anything else but learn about weather. And here I am with the Weather Service and still learning. So as the Weather Service, we don't operate in a vacuum. We work with fellow meteorologists across the field. There's all sorts of different avenues, branches in this field, from broadcast to research to private sector to the military. We all work together to get that best message out, communication, and get the best models available for use. We also work with our partners in the community, the Weather Ready Nation, Ambassadors, Skywarn, Train Spotters, Kokoras, MPing observers, and much more. So it's a very large operation that involves a lot of people in order to work. So if you've never been to our office, which feel free if you'd like to, we give tours. This is kind of a look at what we see on a daily basis at our desk. So you can see we have several monitors that show various model data. We also have observations, whether that's satellites or radar observations. We have our graphical forecast editor, which makes the forecast and sends to the website, and so on and so forth. Speaking of, this is what our website looks like, weather.gov/ABR. And it's got a whole range of different kinds of information, from the forecast to our weather story, which we'll kind of talk about the main focus for the day or for the week ahead. And it's also got the place you want to go to get the current warnings and watches, one of the places. So what is the difference between a watch and a warning? This is something that social scientists have told us is not very intuitive to people that haven't been weather nerds their whole life. So just as a refresher, what a watch is that the conditions means that the conditions are coming together. The ingredients are in place for severe weather to develop. A tornado watch could be in effect with blue skies overhead. So it just means to kind of keep an eye out for the potentially rapidly changing conditions and to be aware of the potential threat over the next several hours. However, the warning means that the threat is imminent. Those ingredients have come together in the worst possible way to produce a threat for that severe storm or severe weather. So taking a step back a little bit, what is severe weather? Well, our criteria for a severe thunderstorm warning is for hailstones to be of 1 inch or greater in diameter, which is about 1/4, and for wind gusts to be at about 58 miles an hour or greater. Our criteria then for the tornado warning is obvious. You need a tornado, and that's basically when you've got this column of rotating air that comes in contact with the ground. Now, that doesn't necessarily mean that the condensation funnel, that white part or the part that is similar looking to the cloud, reaches the ground. So notice in this example here on the left, that white funnel doesn't really reach the ground, and yet you're still getting dust being picked up. So that's considered a tornado. You just need the rotating column of air, visible or invisible, to be reaching the ground. And so it's something kind of to keep in mind when you are out and in the vicinity of severe weather, keeping a close eye as close to the ground as you can, just to watch for dust being picked up or debris or anything like that. Flash flooding and lightning are also dangerous kinds of weather. We don't issue warnings for lightning, but it is one of the leading weather-related killers in this country. And so always best to just be aware of all the myriad of hazards that severe storms can create. All right, so how do we observe the weather, severe weather? We have a lot of different tools that range from satellite to weather stations, but probably one of the most important, not the most important, is the Doppler radar. And this is a tool that sends out electromagnetic radiation towards the storms. And if there's anything that's in the air, then that radiation will bounce back and give a signal. And so basically, there's a lot of different products and information that this can tell us. One of the most important is the radar reflectivity. What that's telling us is how much stuff is there, how many things are in the air, and where is it at? And what we get back is this color scale of intensity. And so you have your light blues, light greens, transitions to yellow, reds, and purples are really heavy rain, and then hail. Another very important product from radar is the velocity. This tells us which direction the hydrometeors, the raindrops, the hailstones are moving. And it comes back with either the color red or green. And so this example shows a straight line wind event. And if you have those greens, or in this case, the blues, that means that objects that are in the air are heading towards the radar. So in this case, our radar is down there in the bottom right part of the radar screen. And so we're seeing a lot of intense greens and blues. And so that's telling us we've got some pretty intense winds at that level. Remember, the radar, it's not going to be at this uniform height as it goes out with distance. The Earth curves, and so when the beam goes out, it goes out in a straight line. But the Earth over time curves further and further down underneath that. So the radar beam goes up higher with distance. So at this height, we're seeing quite the potential for some, or the observations for some very strong winds. And given the environment, we know if it's likely to be reaching the ground or not. This is also an important tool, product, to determine if the storm is rotating. So this is a classic couplet that we'll see on velocity. You can see there, we've got some really bright reds that are right up against the really bright blues and greens. And so that's telling us that you've got really strong winds moving away from the radar, which is the red. That's really close to really strong winds that are moving towards the radar, which is the blues and greens. And that implies rotation. So it's not that we're sampling the tornado itself, but we're sampling the storm's midsections most often. And we're seeing that storm rotating. And again, that gives us a pretty good tip-off, depending on how strong that rotation is for the tornado potential. So there's all sorts of other tools, other products that the radar provides. This is an example of what you'd see when you have a tornado in progress, and not only just a tornado, but a tornado that's doing damage. The top left is your reflectivity, the top right is your velocity, and the bottom right is what's called correlation coefficient. And if you see those blues, that's indication of debris. And so even without seeing anything outside, without seeing any, looking out any windows, without looking at any webcams, getting reports, the radar can tell us that this is a tornado. So let's take kind of a step back again and kind of think about, how does severe weather develop in the first place? How do you go from something like this, where you have clear blue skies, beautiful day, to a tornado? Well, the first step is you need moisture. There's 4 main ingredients that must be met for you to get severe storms. And you need there to be moisture available. That, in our part of the country, in the northern plains, comes from the Gulf of Mexico. And so typically you'll have low pressure systems that develop across the western part of the country. They move to the east. As they do so, because they rotate counterclockwise, they'll bring up southerly winds. Those southerly winds will transport the moisture and lead to increase in humidity. And so your dew points will climb into the 70s, sometimes even into the 80s. Another way that we can get moisture, especially during the late summer, is through evapotranspiration. That comes from the crops, from the corn crops especially. They'll bring up a lot of moisture from the ground, and send it off into the air through that process. And so there are times when we can get dew points even into the 80s, which is ample moisture for thunderstorms. But all of that humidity and moisture and warm air, it will do nothing if it's not nudged upwards. So the second thing that we need for severe storms is a lifting mechanism. That can be in the form of like some topography, for instance, perhaps the Black Hills or something like that. But typically here in the northern plains, it's going to be a cold front or some other kind of front. In the case of a cold front, like in this example, cold air is more dense than warm air. And so it's going to undercut that warm air and lift it up. And once that storm, once the air starts to rise, it starts to condense, forms a cloud. But what happens after that depends on how unstable the environment is. Stability is determined by what the temperature does as you go up with height into the atmosphere. So if you have like a warming with height, that's a stable environment. And that cloud, once it's shoved up, it's not going to keep going up. It's going to start to flatten down. But if the air is colder as you go up with height, then you're going to continue to get condensation, and it's like a domino effect from there. The final thing that you need is wind shear, and all else being equal, this is what determines how organized your storm is and what its potential will be in terms of the severity of the severe weather. So wind shear is just how your wind is changing with height. You have a lot of wind shear if your winds start off on the lighter side of the surface and get very strong up towards the top of the cloud. You also can have, that's called speed shear. Then there's also directional shear. But in any case, wind shear is very important because if you don't have much shear, like the example on the left side of that panel, your updraft, your storm's going to start to develop. It's going to climb up and up and up. It's got instability. Then it's going to start to rain. But if it's vertically stacked like that, the rain's going to fall back down on its updraft. And so the storm's going to get choked off. But if you have the wind shear, that downdraft is kind of offset from the updraft. And so it can become a much better organized and much more long-lived storm. So we'll start out here looking at the pulse type storms with the least amount of wind shear. When your wind shear increases, they can transform into multi-cell clusters or lines. And with the most shear, you can get supercells. So again, starting out here with the multi-cells. Pretty good example here. You can see it's a pretty vertically stacked storm. The wind is not doing much with height. So updraft's going to go up, going to fall right back down with that downdraft, all that rain, and the storm's going to live for only about 30 minutes. The biggest threat with this is lightning, hail, and gusty winds. So here's an example from July of 2017. This is from the tower cam that we have at our office at the airport. And notice it looks like a regular rain shaft at first, but look at the bottom right part of that downburst. You see how that kind of curled there? Sometimes called a rain foot. That's an indication of strong winds. It's because when that rain comes down, it's got force with it, it's got motion, brings down some strong winds. When they hit the ground, they've got nowhere to go but out. And this storm did do damage, knocked down some trees out at the Mina Lake area. Another example of a single cell that did damage was to our very own warning coordination meteorologist's house. This doesn't look very impressive on radar, but it had enough of a downburst to throw something into the window and break the window. Another threat with any thunderstorm is lightning. And whenever you can hear thunder, you're in danger of being struck. This is just a very dramatic video of a lightning bolt that was caught on film that struck some power pole, I think, just disintegrated it. Lightning is about 5 times as hot as the surface of the sun. And so it's got a lot of force with it. And that's not something you want to encounter. The safest places to be is in a car or in your home. And really any place outside that's not enclosed is not safe. We've got some pictures on the right there that show really the power, kind of underscore the power of lightning bolts. In the bottom right, one strike killed 21 head of cattle back in 2016. Okay, so when it comes to fatalities, again, this is one of the leading killers, weather-related killers in the US. And there's all sorts of activities all outside that can be dangerous. Anything from construction to farming to boating, camping, riding your motorcycle, your bike, sporting events, being on the beach. And the number one activity, I'll just kind of let you think about it for a second, see what your best guess is for the leading activity for lightning deaths in the US is. It's fishing. So something to keep in mind if you're an avid fisherman, or if you know people that like to fish, don't want to be caught out there during a thunderstorm. All right, moving forward then, increasing our wind shear. Now we're going to focus on the multi-cell clusters or lines. So the storms become better organized now. Its potential for severe weather has gone up. And these storms can last several hours. Really, the main threat is strong winds or flooding. So here's an example of the flooding threat. Notice that this storm on radar is kind of lining out, but it's forming over the same areas over and over. It's called training. This was an example from July 24th and 25th of 2020, where 4 to 10 plus inches of rain was observed in northern Brown County. And the result was lots of washed out roads and lots of issues out at Elm Lake. So again, it's not just one cell that we're talking about, it's this whole series of storms that have congealed and continue to develop over and over. And when they're positioned that way, parallel to their motion, and you can get some very heavy rains. So flooding is one of those underestimated threats. Unfortunately, it's another one of the leading causes of fatalities, weather-related fatalities in the US. A lot of people just think that their vehicle can handle it, or figure that a couple inches across the road isn't really a big deal. The reality is 2 feet of water, just 2 feet, can float away most vehicles. And as you can see in the video on the right, you don't really know what's going on below the surface of the road. Even if it's just covered by a couple inches, there could be issues with the underlying structure. And if you're driving along 60 miles an hour, you might not see this in time. Here's a couple of real life examples of the flooding aftermath, and people's, the impacts from people driving either through flooded roads or on roads that have been washed away by the floodwaters. The barricades are there for a reason, so probably preaching to the choir here, but definitely not something you want to ignore. So the next greatest threat with these types of storms? It's wind. So you've probably all seen this kind of a cloud before. It's called a shelf cloud. This is a cloud that forms when you have rain-cooled air from the thunderstorm that's moving out ahead and undercutting the warm, moist air out in front of it. And so you get this kind of uniformed look to the clouds where it's lifting up that warm air and that air is condensing. Anytime you see a shelf cloud, that threat for wind is there. And, you know, a lot of times we see these types of storms. They're pretty common across South Dakota and Minnesota. Here's just a few examples of some of the more intense ones that we've observed over the past several years. In all of these cases, winds gusted above 90 miles an hour. And for perspective, an EF2 tornado has winds starting at 111 miles an hour. Category 3 hurricane, winds starting at 111 miles an hour. And we've had weather stations measure wind speeds of 122 out near Hayes. We had a gust 95 at Summit, 81 in Aberdeen. So these are pretty serious winds. You know, it doesn't matter what kind of wind it is that's impacting an area. It's still, you know, whether it's tornadic or straight lined, it's still going to do damage. So here's an example, just a time lapse again of a squall line or a multi-cell line that's moving through Iowa, out in Iowa City in 2018. Pretty classic shelf cloud there. This type of a storm is a little less common, but it's one of the most dangerous. It's called a derecho. A derecho is a squall line that's particularly intense and particularly long lasting. And back on May 12th, just this past May 12th, 2022, we had a derecho that started in northern Kansas and went all the way up towards Duluth, Minnesota. And along the way, it produced 67 reports of hurricane force wind gusts or greater, which was and still is a record for the most reports of significant wind gusts in the country on a single day. So you can see in that list there on the top right, some other significant derechos include the one that impacted similar areas from Nebraska up to Iowa into Minnesota in December of 2021, and then another one that impacted Iowa on August 10th of 2020. So these are pretty significant storms, lots of damage, lots of trees down, lots of structural damage, widespread in nature. So when it comes to straight line winds and fatalities, the leading cause of fatalities is falling trees or limbs. That accounts for almost 70% of all of the fatalities. And so it's not something you necessarily really think about when you're driving along and there's a storm that comes up. You know, in this bottom picture here, that tree fell right over onto the road. And a lot of times it is a car where people are stuck in and get into trouble during these storms. Other types of fatality causes from straight line winds include falling heavy equipment. People think, you know, they can take shelter behind some heavy equipment on the farm or elsewhere, construction site, and the wind is strong enough to topple that equipment. And other instances involve boating accidents and others. All right, so this is an example, a test, a controlled test about what an 80-mile-per-hour wind gust can do to a manufactured home. And you can see that roof is not much of a match. If we bump the winds up to 110, it completely peels away, and the entire structure is just exposed. And so, again, vehicles are not a great place to be during these types of storms. Manufactured homes don't stand up to these more extreme examples of wind, but we do observe these from time to time. Popular activity, taking your camper out during the summer. They're, not very good places either to be. Here's just a few examples of tipped campers from strong straight line winds over the past few years. And so again, if you get the warning for that kind of a wind, 70, 80, 90 miles an hour, it's best to go elsewhere. All right, so we're going to increase the wind shear even more now and get to the level that we need for supercells. So a supercell is, some call it the king of all thunderstorms. They are very well organized. They're like a well-oiled machine. You start with your updraft, like any thunderstorm. You've got your warm, moist air that feeds into the storm. If it's a particularly intense updraft, you'll see what's called an overshooting top. And then you have your downdraft that's offset from the updraft. And so they're able to coexist, and the system is able to continue for hours and hours. Supercells can travel hundreds of miles and last for many hours before dissipating. Here's an example on radar. This was the supercell that produced the Bowdle, South Dakota EF4 tornado back on May 22nd of 2010. And as you can see, it's got a pretty definitive hook there and very impressive looking storm on reflectivity and on velocity. You can see the reds going away from the radar, the greens heading towards, clear rotation, strong rotation. Supercells produce about 70% of all tornadoes, yet only about 1 out of every 4 supercells produces a tornado. So they are the most prolific type of thunderstorm to produce tornadoes, and yet it's not, it's more likely that they're not going to produce a tornado than they would. A supercell just means that the thunderstorm is rotating. And so that comes from the strong wind shear. But a supercell can rotate in the mid-levels. And what happens down near the ground is what's most important for tornado development. So if you don't have strong low-level wind shear, your chances for tornadoes goes down. You're just going to have this beast of a storm that's rotating and producing severe weather, but less of a tornado threat. Supercell thunderstorms are also prolific hail producers. Studies have shown that they produce nearly every 2-inch plus hailstone. So what's a couple of clues to tip you off that you're seeing a supercell from the ground? You want to see a lowering of the rain-free base, that updraft, and that's called a wall cloud. So here's just kind of a bunch of examples here of different wall clouds from across this, northeastern South Dakota, central South Dakota. You can kind of tell that they all have that similar look. It's like a kind of a flying saucer type of look. And some even kind of look like they've got some rotation. Some wall clouds rotate, some wall clouds don't. But the ones that are rotating are the ones that you particularly want to pay attention to and watch out for when it comes to the tornado potential. It's important to remember that you're not going to necessarily see this classic wall cloud in every situation. What we have here is just kind of an example of radar image on the bottom left, reflectivity. Our storm is moving off to the northeast, and you can see that blue crosshairs there at the bottom. That's where the observer is in this hypothetical picture on the right is not from this event, but it's what you would see, something similar. Notice that there's not much in the way from where that hook is to where the observer is. So there's not much in the way. There's not much stuff that's blocking your view. And in this case, with the supercell, if you'll notice on the map where Tuscaloosa is, kind of where that hook is, that that kind of ball of red and white, that's where the tornado is located. So again, if you're positioned, say instead, where the tip of this arrow is, and the storm is moving northeast, and you're trying to spot, where's the tornado at, you're not going to see it until maybe it's too late, because you'll be in that really heavy rain and hail region of the storm up until the tornado is pretty much bearing down on you. So kind of perspective, where you are matters when it comes to trying to get a view and trying to get a sense of what you're looking at visually on the ground. Here's a time lapse from western South Dakota of a supercell back in 2014. Pretty classic example here. You've got your really strong developing thunderstorm. On the left, you'll notice that rain-free base. On the right is the rain, kind of a bit of a rain shaft there. On the left, you've got your wall cloud now, and notice the updraft is literally spinning. It's rotating like a top. That's just, validation that this is a bona fide supercell, and you got to be on the lookout for those potential severe weather hazards. Something to kind of keep in mind as well, not all supercells look the same. This example is what's known as a low precipitation supercell. That's the result of just less moisture, and western South Dakota is typically that way. It does provide you a lot better view of what's going on with the storm. You have kind of less moisture, less rain, and other things to block your view of the mesocyclone, of the wall cloud. But there's a more likely chance you'll run into what's called a high precipitation supercell across the eastern part of the state. And good luck sometimes trying to spot anything with those supercells. Tornadoes oftentimes can be wrapped with rain, and makes it virtually impossible to see the tornado within. So again, supercells are prolific hail producers. Vivian, South Dakota, back on July 23rd of 2010, recorded the largest hailstone in US history. And there's three ways that we measure the hailstone. It's the diameter, and the circumference, and the weight. This hailstone broke both the record for diameter and weight, and it missed the circumference record by just a little bit. That record still stands from a stone that fell in Aurora, Nebraska in 2003. So the other two records still stand. Occasionally you'll get reports, you'll hear about reports of 6-inch diameter hailstones out in Texas, out in Kansas, but never before has somebody collected at least an 8-inch diameter hailstone in this country and reported it. Obviously, that kind of ice is not going to be good when it comes into contact with the ground, especially if you're driving. Windshield has no chance. A quarter-sized hailstone will fall at speeds of between about 60 and 70 miles an hour. But a hailstone that's the size of a baseball can reach speeds of 100 miles an hour. So obviously it's going to do serious damage to anything it hits. That includes you. This is an example of a hiker that was caught out in a pretty significant hailstone or hailstorm. So when that kind of hail combines with strong winds, you get what's called a hail or wind-driven hailstorm. And we'll see these from time to time. most recently, August 28th of 2021, where you have just a long-lived, intense supercell that's producing baseball-sized hail that's being driven by winds of 60, 70 plus miles per hour. And it just pulverizes everything in its path. I mean, you can see by the pictures, your siding, windows, not going to stand a chance. The crops in the bottom there, that's what it looked like south of Ipswich after this August 28th storm. And from satellite, you can actually see the hail scar. After the vegetation that's been pulverized dies, turns brown, it actually shows up from space in this large swath. Um, and in this case, it showed up from south of Ipswich over to Webster. And there were other swaths as well that day. All right, so back to the tornado threat. This is a video, not a time lapse, a real-time video of a supercell thunderstorm out by Albert Lee, Minnesota during the state's largest tornado outbreak in its recorded history on June 17th. Just focus kind of near the ground where you'd expect underneath that wall cloud where a tornado might develop, and watch how quickly it does. So literally within seconds, you go from not even a visible funnel cloud to now what looks to be a pretty solid, intense tornado. And indeed, I believe this one went on to become an F4. Some things to keep in mind with tornadoes, their motions can be extremely erratic. So just because the storm is moving off to the east or southeast or northeast doesn't mean the tornado is going to do that as well. This is a good example of that. Back in August 30th of 2020, unfortunately was a fatal EF2 tornado just north of Miller. But notice the storms are moving southeast, east-southeast. But on the bottom right here, this is the path. The tornado went from just to the east of Highway 45 and traveled due north before turning northwest and eventually southwest before it dissipated. So in the picture, you can see how elongated that tornado became, and yet it was on the ground in a direction that was opposite of the parent thunderstorm. Here's another example just recently from April 19th, down in Oklahoma. These are the storm surveyed storm tracks, tornado tracks from that event. And again, I mean, just because the storms were going east-northeast, you can't assume that the tornado is going to follow perfectly in that straight line following the storm motion. These tornadoes went anywhere from east-southeast to northwest. And the reason why they do this, a lot of times supercells are cyclical in nature, so they'll produce a tornado, that tornado will lift, another tornado will develop a little bit later on, and so on and so forth. Well, sometimes the tornado will become detached from the parent thunderstorm towards its end of its life cycle. And so it's free to move, move in a different way. And what that's dictated by is what the winds are doing in the lower levels. So you've got your mid and upper levels that are steering the thunderstorm, in this case off to the east-northeast. But when that tornado becomes detached from the parent thunderstorm, it's a lot less tall. And so it's going to only be feeling the winds that are in the lowest level. And typically that's going to be out of the south or southeast, hence the northwestern motion of the tornado. So again, it's something to keep in mind if you are out and you're seeing a tornado, if it's going one direction at this particular moment in time, doesn't mean it's going to continue in that direction. Also, because these supercells can be cyclical in nature and produce tornadoes, multiple tornadoes. Sometimes they overlap. This is an example from Iowa in Bondurant in 2018. And you can see clearly there's two either tornadoes or funnels. And so, you don't want to get too focused. If you are seeing a tornado, make sure to kind of be aware of your surroundings from time to time as well. So one of the worst places to be, if not the worst place to be, is in your car when it comes to tornadoes. This video on the left shows a weak tornado that's going through a parking lot. And those cars are just like picked up like matchbox cars. There's just no resistance. They're no match for that kind of wind. And if that tornado didn't have any debris, that would be bad enough. It can pick up those cars all by itself. But if there is debris in the tornado, it's gonna have an easy time puncturing through the exterior of the car. So there's some examples on the right of the aftermath of a tornado and how the vehicles fared. The safest place to go during a tornado is the most interior room on the lowest floor. So the video on the left is of a security camera from a bank in Parkersburg, Iowa, as an EF5 tore through. Banks are typically pretty strong, stable structures, and it just didn't have a chance. On the right side, this is a picture of an actual survivor from the Wynnewood, Oklahoma EF4 tornado in 2016. This boy got the warning, went to the most interior room of his house, which happened to be the bathroom, and survived. This was what the scene looked like after the tornado passed by, and those were the only walls left standing. So it's good to always have a plan. Tornadoes can develop at any time, really, and whether you're at work, home, school, traveling, you don't want to be caught off guard. This is an example from December 10th and 11th in Kentucky back in 2021. This EF4 tornado collapsed a candle factory, and 8 fatalities resulted from that factory. Closer to home, this is kind of a breakdown. It's kind of busy, but it's a breakdown of the number of tornado warnings that our office has issued by year from top to bottom. It goes from 1986 down to 2022, just last year. And then from left to right is the month that those warnings were issued in. So you can kind of get a sense for when we have our peak severe weather season as far as tornado potential goes. Got your May, June, July, and August, typically. But it varies, from year to year. Last year, we had quite a number of tornadoes in May from the outbreaks on the 12th and the 30th. And there were several other days with tornadoes too. That's not typical. June is typically our most active month, but it's good to be aware that there can be fluctuations in that from that normal. In 2021, that was kind of a good example the other way too. We had two pretty compact low pressure systems that worked through the state that had enough low level shear and enough instability, and they produced several tornadoes across northeastern South Dakota into west central Minnesota as well. So that's not very normal, but it can happen. Kind of looking at the same thing again, it's dealing with tornado warnings issued by the Weather Service in Aberdeen. but this time it's based on the time of day. So we're looking at the percent of tornado warnings issued by the time. So from this, you can see that peak there between about 6 p.m. and 9 p.m. That's the most likely time for tornadoes. Typically because that's when you get an increase in the southerly winds, which increases your low-level wind shear. But, I mean, there's really no time when that percent drops to zero. You know, tornadoes can occur kind of during that afternoon, supper time, but also in the middle of the night. Finally, just wanted to show that there's no real safe place from tornadoes. This is a map of all the recorded tornadoes across our region from 1950 to 2021. And they're color coded by intensity of tornado. So the blue is the EF0s, green is the EF1s, yellow EF2s, and so on and so forth. So if we break away those EF0s and EF1s and only focus on significant tornadoes, still pretty good distribution of those most intense tornadoes. And yes, South Dakota has only had one EF5, but several EF4s. So with that, you know, reports, real truth, real ground truth really helps our entire warning process. So just wanted to throw in a plug there. If you ever do see anything in the way of large hail, damaging winds, or funnel clouds, tornadoes, anything of concern like that, flooding, this is how you can get a hold of us. But yeah, I'd be happy to take any questions if you have any.
I guess one question would be, what do you recommend for EMS providers if they're out on a call and the weather starts to escalate?
Yeah, well, you know, if you're in a car, you're out kind of exposed, you want to first be aware of what's your threat. You want to be aware of what the warnings are. Is it a severe thunderstorm warning? Is it a tornado warning? You know, if it's a tornado warning, especially, and you're out there in a car, you know, out on the road someplace, you want to try to find some shelter. Just, you know, you want to drive to some building, some structure. Try to get into a better place to be, because you're very vulnerable in a vehicle. You know, if it's worst case scenario and there's nothing around, and you know, you're in a tornado warning, it's sometimes advisable to get out of the car and go into a ditch, get into a low-lying ditch area. It kind of depends on the situation, but yeah, you know, it's always best, if you can, to find a better shelter.
It looks like there's some comments in the chat that said, thank you very much for this information. Thank you for a very informative class. Really good training with storm season right around the corner. If anyone in the audience wants to unmute and talk about any times they've had, what they've done during a time where they were on a call, where they were maybe had severe weather that they encountered, you guys are more than welcome to share. Well, then, with that being said, I think we're done then. Thank you very much, Ryan. We appreciate it. And I know if you check out the comments, they're all very positive on your presentation.
Great. Yeah, I appreciate it. Thank you very much again for having me.
Awesome. Well, Thank you, everyone. Have a good evening.